I'm doing a performance test on the HX108-2 radio, and we're going to do a little comparative testing here. Now in this video you're going to see the construction of this radio, the red radio, by me and a friend of mine. My friend has little electronics experience, so this is going to give perspective from two different builders. And these radios were sent to me by Banggood.com for assembly and review and analysis, and you can buy these kit radios for about $5 each shipped, maybe a little bit more, so they're a great deal. So we are out here about 230 miles from my home, Los Angeles, and we're going to be demonstrating these radios on KNX, which is a 50 kilowatt clear channel station. You can see it's right in the middle of the day, and it's just barely coming in. It's buried in the noise. This one here was constructed by a friend in Utah. This one was constructed by me. I ended up aligning both of them. If you watch the rest of the video, you'll see the whole story. So let's just get right into it. I've tuned them all to KNX. We'll start with the notorious Zenith Transoceanic.
It's 3:31. There's now another proposed initiative to overturn the state's recently approved gas tax and vehicle fee hikes. KNX 1070's Claudia Piscuta is live.
Here's KNX on the 80s General Electric IC. Let's try a 60s Arvin.
Looking into this, and the investigation began.
The decking has been placed on administrative leave.
State Assembly's passed.
That squealing is the camera. Let's try a Zenith Royal 780 Navigator. I almost think there's something wrong with this radio. This is a 60s Motorola portable.
The union says in part, the chief is putting out a false narrative to cover up his disastrous policies. Karen Adams, KNX 1070 News Radio.
Okay, next we have a Panasonic. This is my friend's kit radio on KNX. This is my kit radio on KNX. So there's a demonstration of several AM radios in a very low signal environment. You can see that the kit radios actually perform very well for being a cheap kit radio that arrives at your door for around $6. So I give the performance actually a thumbs up. They're not going to keep up with the Arvin or the Transoceanic, but we know that. Those radios cost a lot more. I think these are stickers, aren't they? This is a video on building the, looks like HX108-2. This would be a 2IF stage AM radio kit, super heterodyne radio kit. And this is one of 3 or 4 items that was sent to me by Banggood.com, which is like a Chinese Amazon for evaluation, and this kit is completely unassembled. These kits are unbelievably cheap. Shipped, this is going to be around $6 shipped. So, and it seems like it takes about 2 weeks to arrive to the United States, which is not bad. The parts look of decent quality. So I'm kind of excited to get this together, and it's probably going to be a lot of technical things I'll be going over in this video, but anybody who's learning electronics that wants to pick something like this up to get started, this would be a great way to kind of get your feet wet and learn some of the basic stuff like resistor color coding and types of capacitors and alignment. We're going to do a full assembly and alignment of this thing. There's a complete parts list here, and here are the numbers to, I guess those are the Chinese, the characters there reference to the colors for resistors. So it's going to be, this won't be much for me to assemble with my eyes closed, but for a newbie you probably would want to print out a couple online references to resistor color codes. Now here are the ingredients, and you want to mix thoroughly and bake at 350 for 25 minutes. Let me sort this stuff out and we'll take a quick look. So we'll take a look here at what we got. So we got our circuit board, PC board, our speaker. That's our, whatever you want to call that, decal. That's the back of the radio. These are the knobs. I have no idea what this is. I'm sure that'll become apparent when the time comes. Our IF transformers and oscillator coil. Our screws are here. We got some disc capacitors, transistors, resistors, tuning capacitor, volume control variable resistor, some diodes, battery terminals, 4 electrolytics. We should probably recap this thing before we even build it. A ferrite bar antenna and the coil that goes on it, and our wrist strap. So those are the goods. Now in AM radios, these type of, well, radios in general, these type of IF cans are color coded, and this is usually how they're installed in an AM radio, and we'll see if we can verify this with the schematic. But red would be the oscillator coil, converter coil, then yellow would be the first IF, white would be the second IF, and black would be the final IF detector. And that does seem to correspond here. This would be your converter coil here, because this is your converter. That's your bar antenna. So this would be your first, what I call the oscillator coil. So look at that symbol there. I don't know how to describe that. But you come over here and you look at your resistor color chart, and you find that same symbol there for number 2, which number 2 on a resistor is red. And then we come back over here and we go to the second, or the first IF, sorry, the first IF transformer, which is that symbol there. And so we come over here to what would be yellow, and we find the same symbol, because number 4 on a resistor is yellow. Then we come over here to the third one. See, well, it's hard to do this with the camera. So 1, 2, 3, and we get that symbol there, which I'm suggesting would be white. What's white on a resistor? 5 or 9? Yeah, I guess it would be 9. So we find the same symbol here. So that is correct. So the IF transformers go red, yellow, white, black. This is a Panasonic AM/FM, so it's got a few more transformers, but you can see the standardized red, yellow, white, black with the detector diode there. Here's the radio we're building. Red, yellow, white, black with the detector diode or detector transistor here. Now the next thing I would like to identify are the audio output transformers, and pretty sure there's no colors here, but well, actually there's a Y. So would the Y be for yellow? Well, let's verify that. There's a mistake in the schematic here. This is not an auto transformer, and we can verify that. This should be a separate winding on this side of the solid black line. The solid black line indicates the iron core. So this one here should look like this one. See how this one, there's a coil, then there's a core, then there's a coil. This should be the same thing. So what we can do is we can measure the side with two legs, and the lowest ohm, the speaker, the one that the speaker connects to, should be around an ohm or 2 ohms. It's going to be very low. So here's the yellow, and the yellow is measuring 1.6 ohms. Here's the green, and the green is measuring 160 ohms. So it's obviously the yellow. So I guess that Y right there does indicate that that is the yellow transformer. Now the next thing I'm interested in is the ferrite antenna, and this shows like 3 loops there and 4 there. Well, you can see on this we have a whole bunch of turns here, a few turns here, and a whole bunch of turns on the red. So is this an accurate match? How do we verify that? There is an A right here. I'm not sure what the A is referenced to. And it looks like the mystery plastic piece holds the bar antenna. I think the bar antenna is going to be the very last thing I install, because I have no clue where the wires go on the circuit board here, and I'm not sure what the primary and secondary are. Now I would imagine you really can't screw it up, because if it's part of the oscillator circuit, so if you were to get them mixed up, it would probably run way off frequency. They use an interesting method of regulation here. So we come in with 3 volts, and I can't wait to see how this thing performs on something as low as 3 volts. So we come in here, we got a 220 ohm resistor, and then we got 2 diodes shunting this to ground, so that would be like 1.2 volts or 1.3 or 4 volts to run all of this stuff. So sure seems like germaniums would function a lot better with that low of a voltage, because germaniums are like 220 millivolts, where silicon is 600 and something millivolts. But we just got to try it. And we actually have some specifications here, which, even though it's in Chinese, we can still kind of figure it out. So our frequency range is 525 to 1605. Our IF is 465, so it's not a 455, it's a 465. And I guess 20 milliamps is the normal operating current, and 180 milliwatts is the output. A lot of your resistors are going to be installed like this, as you can see on here how close together they are. So they're going to be standing up with one lead exposed and looped like that. And in general, the way I would go about assembling this is, for instance, in this circuit right here, this is ground down here, and this connects to the emitter of this transistor, which is going to have a signal on it. Well, I would want to put the exposed loop side, so I would want to put this side right here down here, so that the exposed part the unexposed part right here with the RF on it, which would be this part down here, would be right up against the board. That way your ground is exposed, and that way you don't have this stray capacitance and stuff floating around on here. Now I don't know if that really matters, but if you're gonna take the time to assemble it, you might as well assemble it right. Here it really wouldn't matter because you're shunted off with this capacitor. Here there is no, you might want to put, it's only 51 ohms, but you might want to still put the exposed side on the ground. And you know, just go through it. And here, for instance, you would want the exposed side on the ground, and you would want this side right up against the board. So this is the short end, this is the long end of the resistor. So I'm going to go through and populate the board, and I'm going to start with our big items first. I'm going to start with the IF, the transformers, the variable tuning cap, and then I'll move on to the smaller stuff where I can take my time a little bit. We've only got, they've really simplified this down. Almost all the resistor, all the capacitors are 223, which would be 0.022. Just a single 103 here, which would be 0.01 microfarads. And then we got these, which of course are polarized, so we have to get them in properly. And the diodes, we have a 1N4118 here and two 1N4148s there. I wonder if that's a typo or if there's any way to actually identify the difference here with these. We do have our 103 right there, our single 103. Alright, these diodes are all smudged. I cannot read the text on these, even with a powerful magnifying glass, and I'm measuring them on the diode check here, and the forward drop on them is all almost identical. So I'm leaning towards this as a typo here on this, and that they're all the same. Now the transistors are pretty much all the same, so 9018, 9018, 9018, 9018, and then we have 9013, 9013, and 9013. So we got two different types of transistors, and yes, the writing is legible on the transistors with a magnifying glass. And I was able to actually kind of make these out in a microscope, and they all say 4148 on them. So this right here is a typo. They are all 4148 diodes. This here is your bias regulation for your output transistors, your push-pull. The other thing I'm going to do is I'm going to cheat a little bit. I'm going to use my meter to measure the resistors. They're actually, I just spot checked 3 or 4 of them. They look pretty close, but I gotta be honest, these are some of the cheapest components I've ever worked with, so I almost want to just verify that they're good before I install them. And that's fine to do that. That's not, I don't see that as cheating. If you're getting into electronics, it teaches you to use your meter, the different ranges, and you can look at the color codes and then look at the value and kind of memorize the resistors. This is going to be a really long, detailed video on this kit. We're going to go through every aspect of this thing, and if I see somewhere where I think I can make it better, I'm going to do it. Like maybe these capacitors right here. I don't know if that's going to show up, but they are branded JFY Con, and -40 to 105 centigrade. Really? Here's one of our transistors, S9018. I have no idea what that is. And you take a look at the PC board, you'll see these little things like those two things right there, and you see there's 2 here with a split. See there's 2 there with a split. And you'll see, you know, a couple sections, here's 2 with a split. And the purpose of that is on here you have current ratings like 1 to 2 milliamps, 0.4 to 0.8 milliamps, 0.18 to 0.22 milliamps, and those are basically breakpoints so that you can current draw check every stage before you, I guess, bridge them all together and try it. This is educational kits, so that's a good idea. So if you were to measure your current here and it was off, then you would know that there's something wrong with that stage. And I believe this little X here with these two arrows pointing at each other, there's one there, one there, one there. These are the breakpoints on the circuit board, one here. So for instance, the audio driver stage should be 3 to 5 milliamps measured here. So I don't think I need to do that. I'm either going to turn it on and it's going to work, or I'm going to get the high-tech 1965 signal tracer out on it. And the little characters are underneath the IF transformer. So red, yellow, white, black. So the first thing I'm going to do is I'm going to screw the condensing variable condenser down to the board right there, and I'm going to use a little Loctite on these screws because I can't tell you how many radios, small AM transistor radios like this, that I've worked on where those screws had fallen out because you're constantly torquing on them when you're changing the station. And actually I just noticed this. They show you how to hook up the bar antenna on the back. Gonna do just a quick soldering tutorial here. There's nothing to it. You don't need a fancy iron, contrary to popular belief. Maybe if you're doing surface mount stuff, but this is a 35 watt Weller iron. I think I've had this for about 20 years, and I'm just using some solder. I do try and wear gloves and do this stuff outside to try and minimize the lead intake. You know, if you're doing it all the time like I am, then you try and minimize the exposure. If you're just building one kit, well, go ahead and, you know, smoke the lead. It's probably not going to hurt you, but anyway, I've installed that, and I'm going to try and do a little tutorial here. Let me see if I could get the camera set up. It's really not that difficult, but we'll try and do that right there. So what I'm going to do is, so that was red. The next one is yellow. And of course, where is yellow? So yellow, here's yellow. And surprisingly, these parts all fit into this board very nicely. So the way I do this is, the first thing I do is I just get it in there. And what I do is I solder, and again, this is difficult with the tripod in the way. I solder the and you don't, what is that? I solder the grounds first, and I leave all the other pins open. And then what I do is I put my, let's see if I'm in frame here. I put my finger on it like this, and I push in while I heat these up, and I let it seat. And so now it's seated real nice. And now what I can do, let me see, get this in frame. Now what I can do, since it's seated, is I can go around and I can flow the rest of these. And again, you don't want to stay on it real long. Just like that. That's yellow. Yellow has been installed. Alright, so we'll do one more here. We'll do black. And of course this is where having a camera operator would really help. So some people, you know, would bend the things over or whatever. I'm not going to do that. Now, one thing I am doing is I'm going through and I'm checking every single one of these parts with an ohm meter, because this stuff is so cheap. I have no idea. You know, I might as well check it all before I put it in rather than come up and do it later. So on this one we don't have a solder pad for the ground, so I'm going to do, let me make sure I'm still in frame. Yeah, it looks like it. I'm going to do that one and this one just so they're kind of opposing. And then what I'm going to do is I'm going to put my finger on it and push down and heat that one up. Heat that one up. Just make sure it's sitting down on there, you know, flat, so it's not cockeyed. Now let me try and do this. Let's zoom in here real tight. Nope. About right there. Now I'm going to try and solder it. You can see exactly how I kind of do it. So come in here. Come on, don't move. Put that there. And just 2 hands. Don't put the solder on the tip, and then hold the tip up against it. Just like that. You can go over it with a clean the flux off and then go over it with a magnifying glass afterwards. Now those are what I would consider our large items are populated, and you can see right there I actually bent that lead over and used it to bridge that stupid current checkpoint. I don't care about the current checkpoints. And then those two there I didn't cut, I left them long to attach the speaker leads to. I don't like using solder to bridge big gaps like that. That's just a recipe for a crack in the future. But anyway, yeah, we want this thing to last 50 years at least. I'm serious about that. Why, you know, it's the kind of thing you build when you're a kid and you pull it back out when you're a senior citizen, and it should still work. If the AM broadcast band is even still used, who knows, Rush Limbaugh might still be cranking away in 50 years. I've installed the 4 electrolytics, and it's labeled on the board clearly the positive and the negative, so there's a thumbs up for that. And I actually tested the electrolytics and they were acceptable. I feel like that's one area where you could probably upgrade if you wanted to go with Nichicons. There's 2 100 microfarad at 10 volts and 2 4.7 microfarads at 10 volts. Now what I'm doing is I'm testing the transistors in this crappy meter. This is just like a generic gain reading, but you know, it'd show if one of them was shorted or open. So I'm going to populate and solder the transistors now. Well, I kind of caught my first mistake, and it's not really a mistake, but we look at the transistors. So the audio outputs are 9013, the driver is a 9013, the detector is a 9018, which I attempted to replace that, try a germanium diode or a 1N60P Schottky in there and see if that improves it. So 9018, 9018, 9018, 9018, and measuring the gain on the 9018, it is 73, and measuring the gain on the 9013, and this one is 244. So the gain on the 9013 is 244, and the gain on the 9018 is 75 about. Well, they gave, looks like they included an extra transistor. So what I did was I installed the 3 in the audio section first, and then was just going to pop the rest of them in, thinking that they would all be 9018s. But it looks like, unless I'm missing something, they included an extra transistor here. Converter oscillator, first IF, second IF, detector, that's got to go. That just looks stupid. Audio amp and audio output. Time for the resistors, I guess. R5 is a 150 ohm. They let us know that twice. R9, 680 ohm. R9, 608. R9, well, blue, gray, brown is 680 ohms, and they kind of painted the brown a little bit on this. There's like blue, gray, brown dot, and we have 670 ohms. Alright, all the resistors are in. Let's do the diodes now. All the resistors lined up. I don't have any extra parts. Still have this extra transistor here, but let's do the diodes, and I already checked them. Small diodes like this are polarized, and you can see in this case here, the small diode and the symbol, they have a black line painted on one side, as do the ones in the kit radio, and you can see that the black line indicates the flat side that the arrow is pointing towards. So these are, you can see there with the symbol underneath it, the black line, these are polarized, and they do have to go in the right way. I'm not going to test these disc capacitors. They're all 223 except this one, which is 103. So I'll put the 103 in first, and then I'll just bang the rest of them in. C1, C2, C2, C4. So C2 number 2 is 103. Actually, it's C3. Okay, number 15, C1, CBM223P. What the hell is that? Is that a bodge job on the bottom of the board? What is that? Okay, so C1 and C1 are obviously the tuning capacitor. So CBM223P, they show going from here to here. What the? Okay, I gotta admit, I don't know what this is. And what I'm gonna do is I'm gonna install all the rest of them and just go through process of elimination. I should know what that does, but it's not obvious to me right now. Okay, well, I have run into a problem. I am on C11 right there, and I still got C12 and C13 to go, which C13 goes right there, and C12 goes right there between the output transistors, and we can look at that. Let's see, C12. Yeah, I love how C13 is just, what is C13? It's, where is it? Maybe, no, that would be inside the IF can. So C12 is this right here. That is a bypass. I wonder why they just picked 0.022 for everything. Anyway, I am missing 2 capacitors, and I am still baffled about this CBM223P. I have no idea what that is. No idea. I'm completely stumped. And I'm missing two capacitors, and I'm going to send one of these kits to one of my mine exploring buddies to build, and he watches all my videos, and I wanted him to make a video on building it and get his take on it. And if I'm going to send him something that doesn't even have all the parts, how would I expect any success? Alright, let me look over this place. Okay, see those little blue capacitors there? They're 103, so they're 0.01. I believe they call those monolithic. What I'm going to do is I'm going to change that one and that one to the 0.01s. These capacitors are just to kill feedback and oscillation. 0.01 will be fine. I think they just went with 0.022 on everything just because it was cheaper just to have one value. It's not necessary. I looked at some schematics and they were using 0.005 in that slot. So I'm going to remove that one up there and put it up there, and that using the two blue monolithics there should fill it out. I have my two monolithics installed there as the decoupling bypass anti-feedback oscillation prevention, whatever those things are. And then I moved C13 up here. Now I think what I'm going to do is I'm going to break from this right now, and I have a whole nother one of these that's unopened that I'm going to send a friend of mine to build. And I think what I'm going to do is I'm going to clean this area up, and I'm going to go through that, and let's do a parts count list check thing. The other thing I was thinking about doing is putting the scope on the output of this and feeding like 1 kilohertz sine wave into the volume control, and we'll see how distorted or if there's any oscillation or anything on the sine wave. I don't know. Let's go through the other kit first. Okay, I'm just testing for fit and finish, and it actually fits okay. There's two little notches, one right there and there, that you have to get the board down into, and then there's a single screw right here that'll hold it into the case. So you can see those right there and right there. Now I did find another kind of major mistake, and I've been looking at it, and boy, this would throw a lot of people off, and I'll show you what I find. So we have right here, we have our volume control on-off switch, and if you look at the bottom of it, you have, this is basically one side of it. These three here are the variable resistor. So those three are these three here, and you can see one of these is tied to ground. And here you can see one of the three is tied to ground. And these are the two main leads coming out of the bottom of the switch portion of it. And you can see this is clearly the ground bus. It goes there, it goes over here to the ground on the IF can, it follows through to this ground on this IF can. Well, the switch is obviously switching the negative side, and on the schematic here they are showing the switch switching the positive side, and that is not correct. Now it doesn't matter if the switch is switching the negative side, but you would look at this and you would think, well, I'm going to hook the red wire up to the switch. Ain't gonna work. Here's mine. This one is completely unopened. I'm gonna open this up and do a parts list check before I send this off to my friend. And of course he's not gonna see my video before he does his, so he won't know what's up. But let me crack this open and let's see if there's capacitors missing out of this. Okay, this has the correct number of transistors and it has 9.022s, which is correct according to this if you exclude this mystery CBM223P. So I think before I send this, I'll go through and double check this for him. So on here, see, they actually show the negative going to the switch as I described it. But here, they show the switch in the positive. Alright, we have the signal generator on sine wave fed into the volume control, and I have the scope tied across the speaker. And you can see down here at a low frequency, there is some distortion. Don't look at all these shadows here, but as I go up in frequency, still some distortion there. Okay, it's starting to clip. So that's clipping. So right about there it starts to distort. So down here it looks pretty good. Say from 1 to 2 kilohertz is where the amp is flat and at its peak output. At 1.5 kilohertz, 900 millivolts RMS is about its peak output before it starts to distort and clip. That's a little better if I turn the brightness down on the scope. So you can see it's starting to distort and clip. And that's it. It's not going to put out any more than that. But it looks real nice. Sounds like the speaker's peak efficiency is right there. So loudness wise, it sounds like sounds like 3 to 5 kilohertz is the loudest, but the most power is around 1 to 2.5 kilohertz. And it looks clean enough. I think it's working okay. I don't see any funny oscillation. I was taking a look at this last night, and this piece actually goes right here to hold the AM bar antenna. So I had to undo and then redo my Loctite, which you probably don't need Loctite after all because the plastic there kind of bites down on the screws. I'm working on assembling number 2 here, and I'm not going to make an entire video on it. I did order the 5-pack, the classroom educational 5-pack of these. I think it was like $22 or something for 5 of them. And I'm going to still send one to a friend and have him build it. The one friend I was going to send one to, that kind of fell through due to shipping and embargoes and sanctions stuff, so I can't do that one, but hopefully we'll do a 2-part video here, me and someone else, just to make it kind of fun. So I'll keep assembling this one, and if I find any anomalies I will shoot some video of it.
Closed bag, placed in a car and driven around for hours. She says they decided to let her go when she told them she was the mother of a young child. Authorities say they are investigating. Traffic from the help.
Alright, this one's working. This just the 18650 out of my flashlight, so go ahead and button this one up, I guess. Do the alignment next. This is the second one. This is unit number 2, and this one's working. And I'm going to try changing the detector to one of these. It's just experimental. This is 1N60 is the germanium diode that was used for everything detector wise. So this might work better than the transistor. Look at this. The forward drop on the transistor they're using for a detector is 754 millivolts. On the Schottky it's 214 millivolts, more like a germanium. I tried several different diodes just for the experimentation purpose, detector diodes, and none of them seem to work as good as a transistor. So, and the transistor has no amplification to it. I tried it with just 2 leads. But anyway, this was number 1. This was the first one I built. And this one had 2 capacitors missing and an extra transistor. This one was number 2, and this one all the parts were perfect. So the alignment is way off.
Taylor Swift's left side. Michael brother. We'll see what happens.
So we need to do next, we need to do an alignment on these, and I think what I'm going to do is I'll do just a hand alignment, the way you should do it if you don't have any tools, and then I'll go through and I'll align them with the signal generator. It's been brought to my attention that I really need to address the current break checkpoints that these kit radios have, and what I mean by current checkpoints is, you can see that looks like an X or 2 arrows pointed at each other there, and then up here. So we should, if we measure from here to here with that X open, we should get 1 to 2 milliamps. So I went over this, but we're actually going to demonstrate this, and the checkpoints are on the bottom of the board. You could see one right there, one right there. So we'll go over those. I'm going to assemble another one of these radios, and we'll go over the actually doing the current check. And if you're not going to do the current check, you need to make sure that you bridge all of these. Okay, this is number 3 is assembled. It took me about 1 hour to assemble what you see here. Next, we'll do the current check on the current checkpoints. So currently, as it sits, all of these X's are open right now. So the only current draw would be 4 to 10 milliamps for this, for the audio output, because all of these are open. They're open unless you intentionally close them. So I've got my meter here connected across. This is a 3-volt lithium battery I'm using for testing. I got my meter running, I got it running through my meter, and I've got 9.71 milliamps on the milliamp scale. We'll do this next. We'll check this point. A correction, I'm going to check this point right here. This is the driver transistor. It says 3 to 5 milliamps. This right here should be that right there, that break should be that test point. And I'm measuring 24 milliamps, so there is something wrong there. Okay, it appears I found another typo. Apparently this break right here is supposed to be a break in this. So when I was measuring this at the beginning, I wasn't measuring the current of the output transistors. I was simply measuring the regulation down through these diodes, through this 220 ohm resistor. So it appears that this is supposed to be 8 to 10 milliamps for the audio output, and it's measuring 24 milliamps. So there should be an X in this line right here. Let's go on to the driver. Alright, now I'm measuring against those 2 points right there, which are the driver right here, and this one says 3 to 5 milliamps, and I'm right at 4.77 milliamps, so that looks good. You can see the one I'm measuring there between the 2 probes. That happens to be right here, 1 to 2 milliamps, and that's that break right there, and it's measuring 0.97. It's pretty close. Okay, this is the next one back. It says 0.4 to 0.8 milliamps. It's measuring 0.59. And finally, this is the last one back. You can see it right there. And this one is supposed to measure 0.18 to 0.22. This is the converter. And this one's measuring 0.27, so it's a little over. Why the output stage is drawing excessive current, I don't know. All we have here is a 1K resistor, which I checked is right. The transistors are the right ones. And the 1N4118, which appears to be a typo. It should be a 4148, but if that diode was wrong, it would explain why the bias would be off and the current draw would be high. But all these diodes are the same. They all have the same number on them. Well, I don't know if the thing was oscillating or something like that, but I hooked a speaker up to it, and now it's drawing 7 point something milliamps, and it's rated at 4 to 10, so the radio is also working. So I'm going ahead and closing all of these test points up. Okay, I've got all the test points bridged and the radio's working. So that's a quick overview on what the current checkpoints do. Make sure everything's all the way hooked up, including the speaker, before you test with those. Alright, so we're going together and kind of get some video on how that's put together. I broke these little tabs that are supposed to hold the speaker down. You're supposed to just, I guess, snap it down in there. Not so easy. I'll glue that, and I put the sticker on the knob there, and I got to put this sticker on next.
CBS News, 3 o'clock. CBS News, I'm Gary Nunn. Singer, songwriter, and one-time TV host Glenn Campbell has died. CBS's Frank Sedapanic.
Galveston, oh Galveston.
Glenn Campbell was modest about his success.
Obviously, I've had some pretty good material.
Songs so good that he was all over the radio in the 1960s and 70s. Galveston, Gentle on My Mind. By the time I get to Phoenix, Wichita Lineman.
I've been walking these streets so long.
And Rhinestone Cowboy were among his biggest hits. Asked about his favorite song,
All of it means a lot to me.
Glenn Campbell meant a lot not only to fans, but to fellow country stars like Alan Jackson and Keith Urban, who called him an influence on their work. Frank Sedapani, CBS News. Glenn Campbell had a very public and agonizing battle with Alzheimer's disease. He was 81.
Alright, we're going to just do a quick rough alignment, and we're going to use this And I know somebody's going to be hyperventilating, going, oh, he's using a metal screwdriver. He's going to destroy it. No, I'm not. So you can see the first item is AM570 is coming in at around 800. So we'll deal with that a little bit later, but as you can see,
Casual addition to the Nissan Rogue. Model year end.
so as you can see, the oscillator is way off frequency. All the first station's coming in around 800, so the whole thing is shifted up. You're not getting any of the higher stations in the band. So let's go through and do a quick alignment. So first thing we'll do is we'll tune in a station. Doesn't matter, to something weak.
Commute out to a ship. And the voice is being restored. Mr. Jackson is not acting as a peacemaker. I mean, I told Steve, I never.
It's pretty weak. Okay, what I'm going to do is I'm going to do the 3 IFs to start with. Okay, I'll cover this more in the more thorough alignment, but one of these is an antenna trimmer and the other one's the oscillator trimmer. So one of these will shift the station, the other one will shift, will basically tune the antenna. So we're not going to worry about those right now. The next thing we're going to do is we're going to tune this one. Now there's a couple different ways you can do this. So we know we have a station on 570.
For savings on the last 15 lineup. Hurry, the event ends soon. Shop at your local Nissan dealer and
which that is where 570 is coming in. So what we'll do is we'll put this on 570. Okay, so that's around 570. And then we'll tune this, the camera's interfering, until we get 570. Okay, something's still not right. Okay, I'm going to put it there and try about 1070, and I'll try and find K and X.
Work on toning down. The Korean. Winston Churchill's words stirred his country in the face of the Foundation for a Better Life at values.com. I'm Stu Berger, AM 870, The Answer.
the nation's capital is abuzz after an unarmed Russian spy plane flew over Washington, D.C. today. The low-altitude flight...
So how can 870 be right there?
Several times. Its route reportedly took it over Ohio, Virginia, West Virginia, and Pennsylvania. It also flew over New York City and New Jersey, where President Trump is vacationing.
Okay, let's try this trimmer.
To test its new attack warning system amid North Korean threats. The Hawaii Emergency Management Agency says the alert system...
Decides to dial back. CBS News Update, I'm Pam. The
Threats being traded between North Korea and the United States.
Okay, so that's KNX.
Taken off.
So, how has business been? Rocketed because Trump could pull the trigger any day, and he's dealing with the madman over there. So we got two crazy guys running two countries that are going to probably start a war. Hubbard would like to interest you in the Fall-NATO, a 35-square-foot walk-in closet-like room that is airtight to protect you from nuclear fallout. The cost, $10,000. Brian Ping, KNX 1070 News.
Obama was the best guns and ammo salesman. Trump is a fallout shelter salesman.
Driver, if you're looking to hit a grand slam with your next car, look no further than the Hyundai Sonata. It's the only car in its class with looking for a powerhouse, the and this is the reason to buy now. Get up to 6.
Driver on those smaller streets.
Okay, so now the antenna is way out of adjustment. This is just a crude alignment, but adjusting back and forth between the oscillator coil and the trimmer capacitor for the oscillator, you can adjust kind of the spread, the tracking. So what we'll do now is we'll tune in a station on a higher part of the band. And then we'll peak this one. And you can see that is, my tracking is off because I got that wide open and it's peaked. You don't want it wide open, you want it kind of in the middle. So that would, let me think about that. That would indicate you want to shift the whole thing up a little bit. That way the main variable capacitor was less so that you could make this more. Hey, I've got my low power classic rock station.
I got a Marshall Falk jersey on.
That's caused by the camera.
7th in the league in on-base percentage at .398. Well, the defense was playing the
That's 570. It's a little bit high.
And this picture is evidence, and you see his about that, which is holy. Offers a one-shot skater.
That's the camera.
Given the had to reopen G-Force, one rider.
Washington.
On the YouTube. 그러한 여러 가지
I had my classic hits station. Okay, this one works very good. The battery terminals and the battery compartment sucks though. It's garbage. Okay, this is number 2.
Traffic and weather together every 10 minutes on the Fuzz.
Martinez hitting 5th and right.
Okay, so 570's at about 710 on this one. So what I'm going to do is I'm going to put this one right there, and I'm going to do this one a little bit different. I'm going to tune. First thing I'm going to do is I'm going to try and tune this and bring that down there. And I can't do it, so let's do this. Let's put that in the middle.
Chase Utley picking it up in short right field. At the bottom of the first. Second baseman had problems.
Yeah, I'm going to put that one in the middle.
Running the risk, does it hit the lip where the grass is and give you an unexpected, really weird hop? Well, they played it very cautiously.
Okay, then we'll peek these.
Logan Forsythe, the night off tonight, he's banged up. So Utley starting at second, and at the moment he's shaded towards second base as Adam Rosales steps in. And he takes one out, one ball, no strike. So defensively for the Dodgers tonight, Taylor in left, Peterson in center. He's basically straight away. Yasiel Puig in right. Turner and Seager on the left side of the infield. Utley and Bellinger on the right.
Then we'll peek this one for volume.
Seager picks it up, throws across the diamond. There's 2 out. Mentioned a pregame show that one of the keys for Alex Wood.
Doesn't seem to do anything.
He's undefeated on the road, 5-0 with a 1.55 ERA. Very similar to what we talked about last time with Kenta Maeda.
Up on that. Wild Wings is open late. Here are
We hear from a woman who said, "I'm really in a bad way, even suicidal." She goes on to say she wants to meditate on God's promises. So let's all please pray for this dear lady who's hurting so much.
Want to bring it down a little bit.
70s along with 80s and 90s. By Friday, there could be a chance for those temperatures to...
You supported Donald Trump. You were probably one of the first really prominent public figures to do so. Has anybody from the Trump campaign or the Trump administration reached out to you either directly or indirectly about your conviction?
Well, I'm sure that the people that work for him, they put it together. It's pre. Especially that Vixen.
Still up too high. That should speed it up a little. Then we could just tweak this one for maximum noise, I guess.
On Saturday, security on. Leave a legacy for those you love. Security benefits. Proud sponsor of the LA Dodgers. AM 570. LA Sports. The suburb of difference is the silver operation sales event. Una gran oferta.
See if I can find my oldie station. Okay, there's my oldie station. It's very weak. Let's see if we can bring it in a little bit better. This station's very weak here. It's a low power station in Beverly Hills. You know what? This thing, these radios work very good. Both of these work very good. Wow, look at that. Look at that. Look at the position of the cores. This here is precision Chinese manufacturing. Look at the position of those cores. That's incredible. Next thing we'll do a real alignment on it with the signal generator. And then we'll take it to a rural area and really peak it for sensitivity. Okay, here's the unopened third one. I'm going to send this to my friend, Mine Exploring Buddy, and we'll see how he does with it. I don't know if there's any parts missing out of this or not. Okay, here's what we're going to do. We're going to do just the IF alignment with the signal generator. I have a roll of wire here, and I'm feeding 465. This is not 455, it's 465 with a 1 kilohertz AM tone into this roll of wire, which is just coupled into the bar antenna, and I have the scope hooked across the speaker. Now I'm going to do, which I'm not even picking it up on 465, which is interesting. All I'm going to do is I'm going to tune these three for maximum. So let me see where we're at. So they're tuned at roughly 515 right now. So what we're going to do is we're going to tune them at 465. So we'll just do it by ear first, using the appropriate tool this time. Okay, now what I'm going to do is I'm going to tune them for maximum here. Okay, now what this has done is, because I started off at 515 and now I'm on 465, this has shifted the whole band. So now the oscillator and the trimmers need to be redone to move the stations, because shifting this from 515 to 465 has shifted the whole tuning band that far.
Has accused Quezada of disregarding officer safety and of favoritism.
Okay, that's KNX. That hasn't moved, but the stuff at the bottom of the band moved down. So at 590 is KFI 640 now.
That's how it used to sound when we started this show 25 years ago. We are celebrating our 25th year anniversary on the Dave Ramsey Show this summer. Dig down on what it all means. Also,
I'll tell you, the sensitivity is so sensitive now that the IF is aligned properly. I'm having time even peaking the antenna trimmer because everything's just mashed up against the AGC AFC.
Tim Tebow.
Okay, I'm gonna leave it for now. Next thing we'll do is we'll take it out to the mountains or something. I'm gonna mark the IF cans with a little fingernail polish, like Panasonic does, just because people like to tweak stuff. Okay, I made an absolute mess with that, but at least it matches the blue capacitors I put in that were missing. Okay, looking at the other one, it seems I had it peaked around 535. Remember, it's supposed to be 465. And even though it will work okay at 535, it's still not going to be at peak performance unless it's at 465. So the other thing I want to say is I shipped the other one to my friend, which is 2 states away to build today. This cost $5.50 shipped from China for the radio and shipping. $9.98 for me to ship one of these via UPS 2 states away.
Hey YouTube, the Desdan here. A few weeks back, Shango066 contacted me and asked if I would like to put a little project together for him, a little radio of some sort. And I said, sure, why not? So a few things he said I would need is a cheap micro screwdriver set, some type of clippers, rosin core solder, obviously soldering gun, magnifying glass, and that was pretty much it. My brains, obviously. Additionally, because I know I suck at soldering, I got some solder wick and a voltmeter. That was the other thing, just in case I have issues. I have something to double check. And of course, you should be watching this on the Shango066 YouTube channel. So a little bit about my abilities. I basically have no experience working with PCBs. I can solder. I know a little bit of electrical, mostly working on vehicles. Growing up as a kid, I had one of those Radio Shack kits that you can make a radio, you can make a buzzer, you can do all sorts of little things. And I used to take apart VCRs and build stuff out of them. And that's pretty much my experience, so this should be interesting. Let's see what showed up in the mail. So this little guy came in the mail. Just to skew if anybody's interested, and immediately I see very little English, which is concerning. So let's see what we got here. Alright, so here's our PCB. Fairly small. Should be interesting. Looks like focus. Looks like it's labeled. So that might be helpful. Our AM radio dial, mostly in English. And let's see. Here are our schematics. So I need to figure this out. Oh boy. This is handy, sort of. It's a list of all the parts that come with the radio. PCB with the parts labeled. And a diagram in Chinese on how to read resistors. Oh boy. So, there's that. Let's get to the meat. Here's the radio. Plastic case. No markings on it. Molds well used. A few fixes here and there. Generic Chinese speaker. And a bag of goodies. Let's get into these. Alright, I got my cheap little silicone mat. I like to work on various projects with it. Oh boy, there is a lot of little parts in here. Let's get rid of the cheap Chinesian plastic pieces out of the way. This is interesting. This feels like graphite or ferrite. Huh. Alright, I am going to sort this stuff out, and I will get back to you once I kind of got stuff piled up. More so than it's piled. Alright, so I have everything kind of laid out, sorted out. PCB, little capacitors. Focus. Little capacitors, sort of mount 2 different types. I believe these are little diodes or resistors. I'm not 100% sure. I can't read them. There's super teeny writing on them. Don't remember what that is called. I know it has to do with the antenna part of an AM radio. Some battery pieces, miscellaneous plastic, faceplate for the radio again, some pieces of wire, speaker, a bunch of resistors, and I cheated and I went online and looked up how to read a resistor so I know what capacity or resistance value each has. I believe this little guy here is the crystal, I want to say. I'm not sure. It should be fairly easy to find where it goes on the PCB because there's pretty wide contacts there. These, I know they're adjustable from the top. I've always heard Shango call them IF cans, but those aren't bigger TVs. Not exactly sure what those are called. These two little guys right here look like little mini transformers. Not sure what they are. They're different colors. I don't know how to tell which one goes where. One's yellow, one's green. I'm going to have to probably do some Googling and find out if that has anything to do with their value. This guy, I'm not 100% sure his function. Again, though, easy to find out where he goes on the PCB due to the layout of the leads. A bunch of caps there. And some diodes or transistors. One of the two. These little half moon shape guys here. I got them separated out. A bunch of screws. And then this little guy, I don't know if that's my fortune or what, but that's what came with it. So I am going to start assembling. I will cut you in and out. You really don't want to watch me attempt to solder forever. I'll cut back in when I'm ready. Okay, I'm back. I got the first 2 components soldered on. A little difficult. I ended up having to screw in that guy right back there, as I couldn't get the stay upside down so I can solder him. I had issues with these guys with the bigger holes to solder through. The solder kept running down. I'm not sure you can see it, but there's a nice blob of solder on the underside. So we will see. I am continuing to put components in. It's really hard to, can't solder and hold the camera at the same time. Kind of requires 2 hands. Not sure what to do. These aren't fully soldered in all the way around. It's only on one side. I'm just going to leave it be for now. Alright, I'll get back to you. Okay, I'm back. I took care of those blobs that were on the legs to, I think that's the tuner of some sort. You can see there's less blobs. I just flipped it over, put the soldering iron on the legs, let it heat and let it run down. Still not the best solders, but it's done. Now I'm slowly going to start. I think I'll start at the top here, work my way down. You can see that very top right there if it would focus. There we go, a C13, and it has the symbol for a capacitor. And yes, I had to cheat and go online and see what the different symbols meant, but a simple Google search come up with that. So C13 is a capacitor up top there. We go over the instructions and we find C13, which is part number 27. And it's a 223, my favorite caliber. So if we come down here, capacitors, we got a whole little pile of 223. So one of these. I do not know their capacitors, so I don't believe there's any polarity issues or way it has to go in. Both leads are the same length. So I will slowly start getting some of these soldered in, and I'll get back to you in a minute. And I'm back. Just had a Chinese moment going through. I've been mostly going off of this diagram and this listing of parts, especially for the ceramic, these in the shadow there, ceramic capacitors. Then as I was going along, I realized item number 16 and 17 here are both listed as C2 as far as a location, and one is listed as a 223 capacitance, the other is listed as a 103 capacitance. So I double checked the ones I put in already. I am good so far. None of them have been the incorrect ones. I don't know if they compensated for that and just add another number or what is going on, but you can clearly see there's 2 locations for C2 and 2 entries I should say for C2, and one's a 223 capacitance, the other one's a 103 capacitance, which I believe is like 1 microfarad if I read that right. And so I've had to actually go to the schematic over here and find the C2, and it's actually a 223 and C3 is a 103. So I got that kind of squared away, a little bit of an issue there. So I'm just gonna have to double and triple check everything. Other than that, I'm starting to get some stuff soldered on. Still not the best soldering job. But getting there slowly. I'm kind of working away from the big items I put on, so I can still get in there and still figure stuff out. Still trying to figure out, if you look in the very top corner there, the R1 kind of center screen, there we go, that R1, I don't know what symbol that is. I'm trying to figure that out. Yeah, I'm not sure if that's a diode. I think these little diodes might actually be LEDs. I mean an LED is a diode, so I don't know. Still trying to figure it out one step at a time. The instructions here are superb. Alright, back with another update. I am working in this little corner up here, and now I see got V4 is the next one to do, and it's a half circle. And if I go to V4 on the parts list, V4 is a 918H, and since it's a half circle, and because their diagram, where'd their diagram go? Right here. They have a 918H, so because it's labeled EBC, a little quick Googling tells me it's a transistor and not a MOSFET. Transistor. So let's find a 918H is what V4 requires, and the writing on this is super teeny. So let's see, 913, 913H, 913H. How about a 918? You have to use the magnifying glass, which is not helpful at all. The camera was better. Focus. It's a 918G. Focus so I can see it. And you're not going to focus. Alright, let's see. That is a 918G. I did not see it. When I went through, I didn't see any 918Hs. 918G. Huh. I will 918G. All my 918s are Gs. They say that there's a 918G, a 918H, and a 913H. I will get back to you trying to figure out this little thing, but it's slowly coming along. My soldering, some of these really small guys, getting better. Definitely far from good, but a little bleed over right there, but I believe they were connected. We'll find out if this thing works. If not, I'll send it back to Shango, and let him debug it for me and tell me what I did wrong. Alright. Okay, I'm back and having some issues. Still trying to with those transistors. Let's see, so down here, see these part numbers V123. Let's get the reflection off so you can see. See, it calls for a 9018H, 9018G, and 9018H, 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 and then the 9013H, 9013H, 9013H. When I come over here, it tells you the values for each of those. However, they did not supply me with any of the 9018Hs. They're all 9018Gs. So I don't know if this is a typo and they're all supposed to be Gs on the 9018s, or they just threw some too many of the 9018Gs in and didn't put any 9018Hs. So I'm just going to run with what I have, and for these ones I am going to put all 9018Gs. And let's get to it. By the way, I haven't made any real progress trying to figure that out, but I will start getting these in and I will get back to you. Back, was just getting ready to solder on a resistor. You can see the leads sticking through. If you look at the top part of it, if it will focus, if you look at the top part of it, where am I at? I'm over here. Right there. If you notice, there's a little bit of contact on the copper. So, just barely. So I don't know if that was intentional or if that's a defect in the board. But you can see just barely. Better view. So I'm gonna solder this on and hope not to make too much of a mess. You can see I'm getting along a little at a time. So I am slowly making progress. Another issue that I discovered is down here. These two, I believe they were transistors that go right here and here. They are not labeled of what goes there. Should start with a V. It's not labeled. Luckily, both of them I have left are the same. So it doesn't matter, I guess, which one goes where, but it's good. No, they did not label these. So if you happen to go in a reverse order or didn't follow them, you would not necessarily know which one went there. Other than that, these guys right here, these 4 pads, which are for these 4 cans, I cannot find anything in the schematics. The only markings on them are that. They're all different. In the schematics, they are listed under, I believe, yes, right here in the B's. First couple of B's, and they have these symbols in Chinese after them. That when you go to the schematic in the back, you can see the symbol there is B2, 3, 4, and 5. And I cannot find anything to distinguish which one goes where. Each can has different color. The gray, there's yellow. Each can has a different color, but in the schematic here, I cannot find which one goes which. So I'll probably end up sleeping on it tonight and picking it up here tomorrow. Okay, I'm back on this project once again. I stayed up way too late last night trying to figure out exactly where all these IF transformers, which are different colors, where they go on the board. I got most of everything together. It's fairly easy once I got going and figured everything out. Just the IF transformers. I cannot figure out what order they go in, what spots they go in, and of course, the instructions are in Chinese. So I stayed up rather late trying to figure it out and got nowhere. Absolutely nowhere. So this morning, and actually throughout the day, I thought about it and I ended up contacting Shango, and he gave me a clue to look at the colors of resistors and what followed them. And so I looked at the resistors, I added up all the colors, I looked at the initial color, the ending color, and tried to match them with the color of the IF transformers. Did not work. His clue actually made sense now that I look at it. He actually meant, look on the description, look at an American version, look at a Chinese version, you know that like number 2 is black for the resistor code. And so if we go over and look for that symbol under the IF transformer, and there it is. So we know that B7 is, oh excuse me, nope, B2 is black. So with that said, I took a different route, and I had on my phone, and I loaded in Google Translator, and I just translated the instructions. If I'm able to, I will insert those screenshots here. Okay, so everything that should be soldered on the board, that surface mount, is on. I just have a few wires to attach. First, I need to get the plastic pieces on, mainly this guy to hold the coil antenna thingy on that ferrite thingy. And I'm trying to figure it out. It's a poor fitment. I'm gonna try to get it on this side. You probably can't see. I can see a little bit how it's raised because it sits on these little solder dots. So I'm probably gonna have to grind those down a little bit, file them out, nip them out, do something so it sits flush on the board. Focus. So there you go. So if it sits flush on the board, it doesn't have that gap. That way with the dial that sits on top of that won't have any interference. So that is my next task, and keep doing all these things off camera, sorry, because I can't hold the camera and solder. I will be back to you in 1 second. Okay, all this soldering of the wiring is complete. Everything's in place. These guys are a little tricky. They are really, really thin. I got the plastic piece mounted, test fitted the dial just to make sure it fit. I just tightened it down to kind of alleviate that little gap you can see where it sits up on some of those solder dots. Looking over the board, all my solders look pretty good. There's a couple, like that one center that has a hole in it, but it's good. Connectivity's good. There's a couple pads here. I'm assuming they are test pads, which might come in handy to see where I screwed up when we put this all together. Next task is going to be trying to get everything to fit in this plastic case and get all the wires in the correct order and the battery terminals hooked up in the correct orientation and getting the speaker solder done. Let's have it. Alright, so here we go. I got the final connections on. I just went ahead and popped the speaker and got the things. Got my batteries figured out in the orientation I wanted. Make sure I had my negative and positive set up correctly. This circuit board, trying to get it in, there's some little notches. I don't know if you'll be able to see it, that it has to fit in up top. Kind of see it there above that cap before I shaded it. Real pain to get in and get it down. I got it all down. There is no, I'm assuming this is the volume on and off. There's no detent, so I don't know what's full volume, and I don't know, oh, there is a detent. It's just really sticky. Take that back. Alright, so let's pop these batteries in and give her a try. Is this battery going to fit? It's 3 volts. This is not working out so hot. There we go, that one's in. Sorry, I was looking at the unit itself, not the viewfinder. Power's in. Alright, batteries are in, good contact, no smoke. So far so good. Let's, and by the way, I screwed the board down. That little screw down there was a pain to get in. Make sure you have a magnetic screwdriver. I didn't, so I just went and grabbed, this is a magnet actually, I grabbed that, put it on the end of my little screwdriver. Let's give it a try. Still need to put the dial plate on. Got a decal on back here to get lined up. Let's No volume, no static. Absolutely nothing. Alright. Now starts phase 2 of the video. Figuring out what I did wrong. Alright, it's been a few days. Finally have the time to get back to it. And I am once again working on this little radio, trying to figure out what I did wrong. I contacted Shango, sent him some photos, and he pointed out one thing I missed was apparently you're supposed to bridge those test points. And so I did that. However, I still wasn't getting anything, and it's because I missed a few. Apparently, there's, I believe, 5. If you look at the schematic, there are, where are they at? There's 5 different test points. You can see the values are supposed to be up here. And they are shown on the schematic at the pluses. So, I gotta find the 2 I missed, and Shango was kind enough to kind of circle them on the photo I sent, and I'll put that in right here. And then the other issue I have is apparently I installed the white and black, these top 2 IF cans. I got them switched around. Apparently it's B2 is red, B3 is yellow, B4 is supposed to be white, and B5 is supposed to be black. So it goes 2, 3, 4, 5, where I assumed because it wasn't labeled it went 2, 3, 4, 5, and because this is 6 and that's 7. And so that was an assumption I made, but because this is labeled 2, this is labeled 3, this is labeled 6, and this is labeled 7. So I assumed it went and it didn't. So get back to it. Good thing I bought a spool of solder wick, because I am gonna need it. I'll cut back in once I get going again. Alright, I'm back. Went ahead and saved you the details and got it all assembled. Batteries are in. You can see I switched those 2 IF cans over, and hopefully I didn't screw anything else up in the process. It's together. Let's see if we get anything out of it. Oh, got some noise. That's about all I get of it. Apparently, I also put that decal on. Oh, oh. I should be getting a lot more than that here. Oh, let me. Well, let me see if I can mess with it and see, make sure I didn't screw anything up.
Foods after being snapped up by Amazon, but one analyst says it has yet to rid itself of its whole paycheck image. Charles Grom of Gordon Haskett Research Advisor says Amazon appears to be taking a page from the Walmart playbook, announcing price cuts that on the surface look deep, but in reality are only modest reductions. With the Fox Business Report, I'm Lori.
Seems to be the only station I get. That doesn't sound right. I'm sure it's something I screwed up.
Go to bankonyourself.com. That's bankonyourself.com.
Brad is continuing on service that his independently created when he started Stately Pharmacy in the late 70s.
That they can actually get enacted.
So,
Wouldn't that be refreshing?
let me get this back in the case and see if it still works once back in the case. So, there we have it. Should be getting that one crystal clear because it's right on the hill above me, but radio is complete. Probably needs a tune, which I have no idea how to do. I guess I can read up on it, but for now, it is done. Special thanks to Shango066 for the opportunity to get angry at some copper and wires and components. So some final comments on the construction aspect of it. Everything fits nice and tight in the case, as you can see. Probably could have done a better job routing the wires. One issue I have is that screw right there in between all those IF cans right here that holds down the PCB to the unit. Second time I put that in, it stripped it out, and I was really gentle with it. It's just in plastic. I honestly think that they over drilled or over molded the hole in the bottom that the screw goes into, because it was kind of loose the first time. Other than that, case fitment, there's no retaining really of any. It's just kind of a pressure fit on this. I mean, there's these little clips that probably won't come out for you guys. There's some little clips right in there, and they hold it on fairly well, but a simple little knock around and it pops right off. And the only other commentary on the build is it comes with this little lanyard. There's not really a place to put it. There's this little hole, but once through that hole, there is nothing to attach it to. If you loop it back out, it goes over that lip that the other part of the clamshell goes on. And I'm assuming that that hole is for an FM model of this radio, and they just use the same body design for both and just included that. So yeah, I'm not sure how to attach the lanyard. There is literally no other holes. There's a plus symbol here on the mold. Not a knockout though. Other than that, and something you can't see from here, but on the actual radio dial, I put a Sharpie line on it. It came off a cheap little decal, which you have no way of lining up until it's on, and then when you try to peel it off, it came apart. There is actually a molded in that dial. There's that round red dial back there. There's a molded in line. Unfortunately, it's on the opposite side. So I don't know if that was an error or not. So what I did is I just took a Sharpie and a ruler, pulled that dial off, and drew a straight line across this side, and it seems to line up and work well. Okay, a final wrap up on this guy, and doing some tuning adjustment. So this, I know, is my local 750 station. And if you look at the dial, can't really see it, but the black line is way up here above 100. So let's see if we can drop it down a little bit. Use the red guy here, adjust that. So I believe I want to bring it up, and here it went away. I'm going to bring it up quite a bit since it was a ways off. Back it down just a little. Let's see if we can find that same station now, closer to 750. Or not find it at all. You gotta get a lot of interference in here. I'm not sure what's going on there. Well, I'm gonna mess with it some more. Basically the red will adjust it. The other two are, you want to tune it to kind of loudest. Usually I brought all mine up. I believe the tune over here is set correctly. We'll have this radio checked at a later time. For now, I'm going to see if I can get a little bit closer to where I want it. Okay, so I messed with it a bit.
And welcome back, Hugh Simpson with us, of course. His latest book is Disappear and Reappear. He's written
and you can see I got a little bit closer there.
Website. His last started with me back in September
now just try to
2012.
work on some of the audio.
5 more years.
I think that clicking noise is feedback from either the computer monitor, the computer, or any of the other electronics I have around here.
Get ready for this. We're going live to Mount Fuji, Japan. Oh, great. Hey, Michelle, welcome to the program.
Hi, welcome. Thank you for having me on.
It's just hard to do one-handed and try to show you guys.
I wanted to say that I'm in Mount Fuji. I live here in Japan. I've been here for about 3 years, but I'm actually from North Carolina. And I used to go to school at Appalachian State. Oh my God, no Appalachian State.
I think I got most of these peeked out pretty well. So we'll see. I think probably do a follow-up video on a much later date when we can get this with a frequency tuner doodad thing. Anyway, you've been watching this on the Shango 066 channel, and we'll get back to this little red radio at a way later date.
Okay, Desdan sent me his radio to look over and try and align. I tried to align it, help him align it over the phone, and it's kind of difficult to explain an alignment to somebody who's never done one, let alone without the appropriate equipment. So the first thing I want to do is go over the radio and inspect it, make sure it looks like all the resistors and capacitors are in the right spot. There's only one differing capacitor, and then what we'll do is we'll go through and align it for him. Now he lives in a very rural area and I live in the urban jungle, so all my signals are super hot here, where it's the opposite for him. So he didn't get the speaker in correctly either. This speaker is very difficult to get in. So let me inspect it visually, and then we'll do another alignment on another one of these. Okay, I checked the circuit board. Everything looks good. Work looks good.
Come hungry and enjoy our famous
Folks, that's the skill set that...
We just need to align it. It's just super deaf. Okay, the first thing I want to address is this being out 180 degrees. All you do is take the screw out, lift it up, turn it, and put it back on. Alright, let's align this. I don't know why when you align these by ear... Boy, is that wide, too. So we want it at 465 for peak performance. Got to do the IF first.
We got placed on waivers. He was picked up on waivers at the end of July by the Padres. They put him in AAA. El Paso, ranked 5-star kid, 0.50 ERA after he was claimed on.
So that woke it way up. So as a note, I would say you really have to align these things with a signal generator to get peak performance, because you can peak all of these, but you're peaking them off frequency, and that's not where their optimal efficiency is. Okay, now as far as the rest of it goes, the first thing I'm going to do is I'm going to set these in the middle. Okay, so I'm running all the way up against the upper stop, and I've got a station. So what I want to do is I want to tune it a little bit to push that station down so it's everything's more in the center. Okay, I got sick of trying to do this manually, so I'm doing it with the signal generator. So I got this turned all the way up to max. So that should be about 1610. And it's 1480. So let me bump this up. Let's see. That's it, it's all the way up. Okay, that's absolutely, with this open and that all the way up, that's as high as it'll go. And that's 1770. Boy. Okay, so the spec for this thing is 1605. Now we'll peak this one. Okay, this is 660 AM KTNN, Voice of the Navajo Nation out of Window Rock, Arizona, which is pretty much New Mexico. If it gets this, it's working well. I finally got it dialed in.